fastener. And what I'm going to do is the following. So if you can see on the front of this robot, there's what's called a PSD. It's basically, there's a square surface on the top of there that can sense the location of a laser beam. And what I'll do is I'll manually drive this to within range of this laser beam, and the laser will impinge itself upon this PSD. And then over here, when that happens, you'll see a dot appear on the screen, and the dot will correspond to the location of that laser. I'll flip the switch, and then the laser will move to the center. So the robot basically is able to position itself. The outer robot is able to position itself, very, very accurately to that laser. And then what I'll do is I'll drive to the second laser and do that. Now, the whole time the outer robot is doing a pretty good job of positioning itself, the inner robot is kind of struggling. So we want to show that we can use these Lorentz coils to position the inner robot. So if you see that screen right there, that screen is showing a video from that video camera, which is pointed at the second fastener. So when I get to within range of the second fastener, you'll see the inner robot kind of drive up along and sort of roughly position itself towards that fastener. And then at that time, I'll run some current through the coils, and you'll see it kind of jerk around. So basically, with this system, we've closed the loop on position control for the outer robot, but we haven't closed the loop on the inner robot. Right now, we're basically just using a video camera and me clicking to sort of demonstrate that exists. And that's definitely the next thing I'm interested in doing, is I think it's an interesting controls problem. So, without any further ado, let's get this going. Yeah, be careful with those cables. Yeah. Connecting them out there. So first I'll just drive this out manually. The dead reckoning was. Oh, I need to turn on my lasers, I'm sorry. Okay, so here's the location of the two lasers. Okay, so this light came on, which means that the laser is in view. That dot shows where the laser is, and what I'll do is I'll flip the switch, and you'll see it move to the center there. Okay, great. And just to kind of show you again, for those of you that didn't see, what I'll do is, if you watch the robot this time, when I flip the switch, you'll see the robot just snap into view. So I'll do it now. So it just circles into position. So that's great. So now I'll drive to the second fastener and do the same thing. Okay, and I will now, and as you can see, the inner robot has come into view on that screen over there. Okay, so it's all servoed into position. Now, the inner robot actually looks like it's pretty well aligned there, but I'm just going to show you how I can kind of nudge it around in this instance that it's not well aligned. Because there's no guarantee that it will, there's little guarantee, I should say, that it will. So, you can see it kind of like nudging itself back and forth a tiny amount, like so. Which is good. So it seems to me, I just sort of built this prototype. It seems like I have a stroke of on the order of a 1/16 of an inch or so for that inner robot, and that's basically limited by the fact that the variable reluctance force in those magnets is so good that the macro positioning is better than I had estimated that it would be. So it's a good thing that the stroke is small. That's what I'm telling myself. And the goal eventually is to be able to basically micro position down to 100 micrometers for both the inner and outer robots. And eventually we want to close the loop, so we want to replace the fastener with something like this, something smaller obviously, but has a laser coming out of both ends, such that we can put position detection devices on both robots, close the loop on both sides, and have both robots go right where we want them to go. So yeah, that's it. Any questions or anything?